Good evening, everyone. Welcome to JFrog. Thank you, JFrog, for the pizza and beer and water and the awesome. What you have a room for this, or the name for this room? Frog Vision. So thank you for everyone for being here. I was informed I have 2 hours to talk. 3. He wants 3. Just so you know, Michael asked for 3, so that's what we'll go. So I'll get started. I will not take too much of your time. I'll try to get done here in 30 minutes. So I'm with Netflix, and I'm going to talk about Spinnaker. Spinnaker is a continuous delivery platform that I plan to share with you. But for some quick background, Netflix in early 2016, we expanded into 190 countries, and to support that traffic, we are, of course, all within AWS. We primarily leverage the compute aspect of AWS, which is EC2, but we do make use of a ton of other AWS services like S3, SNS, you name it, CloudTrail. And in order to support a global footprint, we stream out of many different regions, and we have many different accounts. And we believe so much in the value. This thing is, I'll just keep playing with this. It's like I'm picking my nose or something. It's kind of embarrassing. Very good. Good. So, we believe so much in the value of continuous delivery that we invested in a platform called Spinnaker. And Spinnaker was built from the ground up, but it leverages the many lessons learned from previous experiments and platforms at Netflix. In fact, a former colleague is in the back who was instrumental in building one of those platforms called Asgard. And so we like to say that Spinnaker is built on the shoulders of giants. And it leverages all those lessons learned from, at this point, 7 years of running exclusively in the cloud and at scale. And like I said, it is the embodiment of more than one system, not just Asgard, but there were other systems, tried and true, battle-tested systems, and a lot of lessons learned about how to essentially run in the cloud at scale that are now embodied as very strong opinions in the Spinnaker platform. And one thing I want to talk about before I go any further is the value of speed. Netflix, at the end of the day, is a data company, and the decisions we can make on that data enable us to stay ahead of our competition, which is, I'm sure some of you know, there are others out there. They account for a very small amount of traffic. Sorry if you're from Amazon or Hulu or whatever. But no, at the end of the day, we believe that we can do better than our competition if we can move faster than them. And continuous delivery enables that, not just for Netflix, but for any company, whether you're JFrog or Ericsson or Marantis, or Riot Games, Blizzard Entertainment. It doesn't matter. The value of speed is what keeps you in business. And in fact, not only is it a competitive advantage for your business, but your customers demand it. In this day and age, we've become accustomed to getting what we want immediately. And when a when a company does not meet our needs, we have many other choices. So if I can't get what I want tomorrow via Amazon, I'll go, to whatever Amazon's competitor is. But I can always get it tomorrow, so I'm sticking with Amazon, right? So that's the value of continuous delivery. That's why we invested heavily in a new platform called Spinnaker. I run delivery engineering. We have 10 engineers working on it, so you can kind of see again the value that Netflix has been placing in it by investing heavily into it. Spinnaker is open sourced. Again, learning from many lessons learned from previous open source project at Netflix is that we decided early on to partner with respect to Spinnaker, partner with other clouds. Even though we are 100% very much happy and leveraging AWS, we knew that if we went out and talked to Google and Microsoft, for example, if we could get them to partner with us, we'd learn a lot from them, and of course they potentially could learn from us. And so that partnership has proven to be amazingly fruitful. So not only does Spinnaker now work with Google Compute Engine, but it works with Kubernetes. It works on Azure. companies like Target and Veritas came out of the woodwork and said, hey, we want to participate in this project, so they made it work with OpenStack. And we're in early conversations with some other companies that have, let's just say, a public cloud offering, and they're coming to me and saying, how can we get involved in the Spinnaker ecosystem, because our customers are demanding that Spinnaker can support this and that. So it's, and another company that we partnered with was Pivotal, who made it work with Cloud Foundry. And so those are kind of some of the major players in the ecosystem, and then there are a host of companies making use of Spinnaker, and I encourage you to check those companies out on the website, which I'll get to in a little while. Suffice to say, it's a very rich and vibrant ecosystem that continues to grow by the day. And I think one thing that makes Spinnaker exciting for the open source community is its pluggability. So we set out from the beginning, again, learning from the lessons learned from previous projects like Asgard, that not only did we want our continuous delivery pipeline to be flexible in terms of where it deploys to, in terms of not just AWS, but potentially GCP or Kubernetes, or even an internal container cloud that we're building at Netflix called Titus, which should be open source sometime this year. But we also wanted the artifact that is a part of a pipeline to be flexible. So not only did we want Amazon Virtual Images, or AMIs, to be kind of that unit of deployment, but we want to take advantage of containers, so Docker files or Docker images, Dockers, containers. One thing that's pretty exciting that we're working on now is jar files. So if I'm a library developer, I don't necessarily maintain or deploy a service into the cloud. I have a centralized library that all these services make use of. And so they now are beginning to leverage Spinnaker pipelines to deploy to, you name it, Artifactory. So finally, does somebody from JFrog work here? We definitely see kind of the unit of deployment to be flexible. We also are doing more and more JavaScript deployments. At the end of the day, Netflix operates one of the largest CDNs in the world. And so when you run Netflix on your browser or your smart TV, at the end of the day, a JavaScript application is downloaded from a CDN, and those assets are being put in the CDN via Spinnaker. So it is very, very pluggable, and I think that's one of the exciting things about that. And one more thing that I did mention that Spinnaker embodies like these strong opinions, and these are opinions again that were formed before Spinnaker. In fact, they were created by, again, the good folks that predate me at Netflix. But this idea, the highest top level element at AWS is an auto scaling group. How many people here are familiar with AWS? Thank you, Carl. And so the highest element they have from a compute standpoint is an auto scaling group. Auto scaling groups are regional, and again, as I pointed out in the earlier picture, Netflix is a global company, so we needed to hire constructs. So we named this thing called a cluster, which is, we didn't create the word cluster, but so a cluster is made up of ASGs, and then on top of a cluster is an application. So an application can have many different clusters, and those clusters can have many ASGs, and that model is reflected within Spinnaker. And it certainly makes the idea of leveraging the cloud for applications a whole lot easier when you think in terms of that. And so Spinnaker has become what we're calling now a paved road. Every team at at Netflix now leverages Spinnaker to move their assets to some environment, whether it be a test environment, production environment, whether it be the cloud or a CDN, or even an internal container cloud. And other teams are now plugging in their platforms into Spinnaker, because at the end of the day, it's a workflow engine, right? It's a series of stages, and the end stage may be a deployment, let's say, to AWS, but there are stages that lead up to that, like a testing stage. And so new platforms like automated canary analysis, or our chaos application testing platform, or squeeze testing, or a new project called Byway, all these things are being plugged in by other teams. They're plugging them into Spinnaker so that you as a service owner can then say, I want to do X, Y, and Z before I make this deployment into, let's say, the test environment. And then I want to do X, Y, and Z before I go into production. So it's a very vibrant ecosystem, again, not only in the open source world, but within our enterprise, so to speak. And Jez Humble wrote a great book called Continuous Delivery. I highly recommend you read it. And he has a great quote in there that I'm stealing this from him, but not really because I'm giving him credit. And he says that, continuous delivery is all about making deployments boring. And the idea is that, previous to, let's say, a continuous delivery strategy at whatever company you were at, and I remember doing this years ago, is that deployments were an event, like we planned for them. Friday night, we're going to do a deployment, all hands on deck, and, it was very stressful. If you do it right, it should be extremely boring. And in fact, it's so boring at Netflix that we do 4,000 deployments a day. They just happen. They're happening all the time, and it just happens. And that's the value of continuous delivery, and that's the value of a platform like Spinnaker. But again, there are other platforms. I'm not here to sell you Spinnaker, by the way. I was having a nice conversation with Michael about Jenkins, and that's a great platform. So I want to spend a couple moments just kind of showing you and talking about Spinnaker. Rather than doing like a live demo and worrying about Wi-Fi, I just have images. But again, it is a continuous delivery platform that is ultimately, can you guys see that? Kind of? Sort of? A pipeline is made up of stages. And stages can be serial or they can be done in parallel. And there are over a dozen different type of stage types. And so I'll get into some details of this one, but here's an example, and the resolution's not great, but what's happening here is you have 3 stages running in parallel, and 2 of them are essentially some sort of test. And then there's a deployment. And then the next one is there's a manual judgment. So you can totally imagine this is essentially a workflow, a promotional process to put some service into some environment. And I think what's interesting here is we're doing a canary. So canary is the idea of standing up a service in production, allowing a small amount of traffic to go to it, and we watch it. And if that canary passes, then there's a manual judgment. So we still sometimes advocate human beings being a part of your pipeline. In this case, there's a go, no-go button that someone can push right there. And then after that, you can see the next stage is probably a deploy to prod. So again, this is an average pipeline. In fact, it's probably not the pipeline that a lot of teams use, and specifically because there's a manual judgment there, and we wouldn't get 4,000 deployments a day if everyone was waiting for a human to press a button. But there are some cases where a human is required. And as I was saying, these stages, there are different types of stages. There's at least a dozen at Netflix. And in fact, when you download Spinnaker and you install it in your enterprise, you'll have fewer than what we have. The idea is that these stages are pluggable. So at Netflix, we have some proprietary stages that unfortunately we can't open source. And I suspect that as the ecosystem grows, other companies will have their own stages that are unique to Acme Enterprise. But there's a list of stages that you can choose to do in this case. Now, I said that it's built on the shoulders of giants, and so Spinnaker is a continuous delivery platform, and it obviously handles all the orchestration of putting something into a specific environment. Another thing that Spinnaker does really, really well is allow you to manage that environment after it's been deployed. So in this case, what you have here is a cluster called API production, and it has multiple ASGs. In this case, I'm looking at 2 ASGs running in 2 different environments. And Spinnaker allows you to work on an individual instance if you really wanted to, or even at the ASG level. So you can click on individual assets, and you have a number of instance actions. So in this case, here's an instance that's gone bad. If you click on the instance actions, there are choices like to terminate the instance or terminate and shrink, reboot it. And you can think of it the same way from an ASG standpoint. In fact, I'll get to that. So in this case, here's an ASG right here. It's versioned. And I can click on this and I have all these groups that I can have all these actions on the ASG. Like I can delete it, I can roll the next one, I can resize it. And this is, you can think of all these manual actions as just things that people may want to do after something's been deployed. The key thing that I want to point out is that Spinnaker, again, because it embodies all these opinions and best practices, it also allows you to do things like rollbacks, which again aren't very easy in just straight up EC2 or Azure Compute. So a key thing that Spinnaker allows you to do is what the rest of the world calls blue-green deployments, what we call red-black. And the idea here is that it takes advantage of immutable infrastructure. And so what you have here, in fact, let me get to the next slide. Here are two ASGs. This one's in a disabled state. And so what's happened here is through a pipeline, these guys have deployed a new version, v341. The old version has been disabled and is hanging out there. This is orchestrated via Spinnaker. The idea here is that this is zero downtime. Obviously, when you update, let's say, a running service, and the key difference between something like a red-black from, let's say, a rolling push is it's really easy to back out should something go bad. And so in this case, they've red-blacked this new version into production, and they've disabled the old one. And so should they find out that this new one, something's wrong with it, it's very easy for them to say, you know what, this has gone south, let's back it out and point all traffic back to the old one. And all they have to do that is basically just hit a button that says rollback. And the key thing is that this is manual, but you can automatically do it as well via pipelines. And so Spinnaker, as this system that's leveraged all these lessons learned, has made it really, really easy to operate at scale. So you can red-black a service into production, and if we detect, or if Spinnaker detects there's an issue, it can automatically roll it back to the last one, and your customers hopefully have no idea it happened. Or if it happens later, you can manually do it. You can kind of see I'm answering some of the questions on why Spinnaker's better than Jenkins. I'll give you my Amazon affiliate link. Just click it a lot. That's how. So yeah, in this case, if I want to manually roll back, I'll click this rollback, and I'll have an option to say, hey, look, I want to take V193, and I want to basically put it to 192. Again, this is a manual way of doing it, but you can certainly do it via an automated pipeline as well. Another thing that Spinnaker provides that we are increasingly making use of, and we think it's a best practice, is this idea of deployment windows. And so at Netflix, it's 7 o'clock, so like everyone except those of us here is watching Netflix here in the West Coast. And so we are very cyclic. And let's say in Europe right now, people are finally going to bed, so let's say European traffic is kind of going into a trough. And so the idea initially came is we can take advantage of peaks and troughs. And if you have a high, let's say a service that's, let's say it's a frontline service, you can say, hey, look, I want to do this deployment, but I don't actually want to deploy this service, let's say, into Asia when Asia's at peak. So I can set a deployment window to say, hey, look, deploy this thing into Asia during the trough and all the other, let's say, regions during the trough. But another benefit of deployment windows is you can also say, because again, remember, all these pipelines are automated. And pipelines are triggered by events, right? Because events could be, I check something into Git, a Jenkins job runs, a Travis CI job runs, I push a Docker image into a registry. Any of these things, or a pipeline can call another pipeline. But all these pipelines, they're triggered by some sort of event and ultimately producing artifacts and are deploying those artifacts somewhere. Deployment windows are a good way to guarantee that those deployments, let's say let's say promotions into prod, while maybe you want to take advantage of peaks and troughs, you also might want to take advantage of having the most amount of people in the office when you do a prod deploy, for example. So, a common best practice at Netflix is to leverage deployment windows and make sure that deployments are only happening between 9 and 5, let's say for particular services. So again, that's an opinion embodied within the Spinnaker platform that you can take advantage of. One thing we spend a lot of time at Netflix doing is this whole idea of, canary. And the automated canary analysis stage at this point is not part of the open source community. But I'm here to tell you that the good folks at Google have teamed with the ACA team at Netflix, and they're working on a generic ACA stage, and they want that to be available to the open source world. So again, that's this kind of fruitful relationship we have with the open source community, in that in the very near future, ACA will be something that any enterprise can take advantage of. And you can imagine this as a phenomenal kind of gate between kind of test and prod. So let's say you throw something into test, you can test all you want. At Netflix, the sheer combinatorics of what we see in production is impossible to replicate in a test environment unless we chose to mirror all of our production traffic, which we to date have decided that it's not worth the investment. So what we do is we invest heavily in canary analysis. And so the idea here is this is a first-class citizen within Spinnaker. I can create a pipeline that says, I want to run ACA in prod as part of my promotion. And so what that means is Spinnaker will stand up a small ASG, it'll actually stand up 2 small ASGs. Imagine you have your version 10 running in prod, it's got, let's say 1,000 instances. We'll stand up a small ASG of version 10, maybe 10, it's again configurable by you, and then we'll stand up the same size ASG for version 11. And then we'll route a small amount of traffic, but equal to each one, and then essentially our ACA platform will watch both instances and do a diff. And what we're looking for is, is version 11 behaving vastly different than version 10? And you have this ability actually to set thresholds. So at the end of the day, our platform scores it, and you could say, if it's less than 90, fail my pipeline, roll it back, and we're good to go. And so again, this is all built into this platform, and this enables us to move with a high degree of confidence and speed. And what I'm just showing here is more canary analysis and this idea of parallel deployments. And so in this case, what we're doing here is after a canary, this one's waiting for a user approval, and then it's going into 2 different regions simultaneously. Lots of good ACA stuff, and this platform is highly it's tightly integrated with all the various platforms at Netflix, and is completely configurable for you to do the same within your enterprise. And so in this case, what we have here is that this automated canary analysis stage is currently running. That's why it's blue. And at any given time, you can come in here and you can actually go and see the canary report. You can click on that link, and it'll take you into the ACA platform, and it'll show you what's going on. And another best practice that we certainly advocate at Netflix is to automate everything. And I kind of laugh because it sounds ridiculous, but we're humans and we tend to not automate everything. And so we continually have to remind service teams, if you do this one-off task, you might as well automate it. And so this is a great example of a team that has automated essentially this pipeline is used in emergency situations. I don't know if you can read it, but it basically says push to any stack in any region now or next window. And so this is the, oh my God, something's broken. I need this thing to run immediately. But the beauty is they've automated it. It makes extensive use of parameters so they can choose which region to go to. It looks like a pretty simple pipeline, but suffice to say it's only used every once in a while in emergency situations. But the key point is because they've codified it in the pipeline, anyone can run this. It's not left to the one guy that knows how to fix prod. In every company, there's always that one guy or gal that's the maven. They're when the stuff hits the fan, it's Ralph, what do we do? We're trying to avoid that. We want it all embodied within Spinnaker so that Ralph can go on vacation and I can run the pipeline if need be. Ralph. It's a great name. Here's another example of just again I said flexibility, and this is an exciting thing that I suspect all of you can make use of at your companies. So I talked about how we do Docker deployments, we do jar file deployments, we do JavaScript application deployments, we do AMIs. Another key thing that we now leverage Spinnaker for is property deployments. So runtime properties. So at Netflix we call it fast properties or persistent properties. And the idea here is that I have a running app. I don't want to redeploy this app to change some property how many people like House of Cards? Nobody? Okay. Anyone here a Netflix member? So you can imagine, you have these challenges at your companies today. I have a running service and I want to make something go live. I don't want to redeploy that service in order to enable, let's say, House of Cards Season 5. I just want to basically change a property and all of a sudden Season 5 is live for the rest of the world. So that's called a fast property. Think of it as like a runtime property. Those are now facilitated via Spinnaker at Netflix. So if I want to change a property, whether it be a global property or scoped to an ASG or scoped to an instance, I can leverage a pipeline to do that. And that's a really powerful notion because we've learned at Netflix that, think of these as feature flags. Feature flags are really, really easy, and that makes them difficult because people shoot themselves in the foot all the time with fast properties. Netflix has had catastrophic production outages because an engineer accidentally fat-fingered the scope of a fast property. So we're now leveraging Spinnaker to quote-unquote deploy fast properties, and we've seen a vast improvement in our availability. So, another thing that Spinnaker does that we find a really powerful mechanism is this idea of notifying and notification strategies. And so via Spinnaker, you can choose to be notified if a pipeline starts, if it fails, if it finishes. You can also do it at the stage level. And we can pump those notifications to email. We actually are finding that nobody reads email. So more and more teams are actually pumping that stuff to Slack. And so you can see here that here's a particular, giving people context to, hey, look, this thing was deployed into prod, into Slack channels. What I think is also exciting is like if there is a manual judgment, we can pipe that to Slack, and people now know, hey, look, this thing needs to be, here's a pipeline waiting for a human to click it. One more thing, when I was saying it's a paved path and all these powerful platforms are plugged in. Anyone here heard of Chaos Monkey? Yes, thank you, Carl. So Chaos Monkey is embodied in the Netflix ethos. We continually run Chaos Monkey. For those of you that are aware, Chaos Monkey essentially randomly kills running instances in environments. We believe strongly that you should constantly test and validate that your services are reliable by just unleashing chaos in your environment. So at any given point, Chaos Monkey is running in AWS prod and is shooting instances. Not in the foot, but in the head in this case, unfortunately. And we expect that these services are resilient to that. And it's totally integrated within Spinnaker. So when you create an app in Spinnaker, you have to opt out of Chaos Monkey. The cool thing is that I know someone asked a question, does Spinnaker work with Azure? Yes, it works with Azure. And guess what? So does Chaos Monkey, because Chaos Monkey works in the Spinnaker ecosystem. So it's a really exciting platform once you think about it from a kind of holistic ecosystem. I'm going to fly through some of these since we're coming up on the half hour. But I was talking about kind of how pipelines are triggered. They can be triggered via a cron expression, again, via a Jenkins job, a git commit. It doesn't matter. There's a flexibility in terms of how you want a pipeline to be triggered. The key thing is pipeline can call other pipelines. Another thing that pipelines support is this idea of preconditions. So I alluded to that you can pass parameters through pipelines. You can check the state of the world if you want before you do something. Remember I was talking about deployment windows? This idea of maybe I only want to deploy to Asia between the hours of, let's say, noon and 5 Pacific Standard Time. A pipeline may kick off, let's say, at 8 a.m. in the morning, though, and so it's going to end up waiting 4 hours before it actually goes into Asia. This idea of preconditions is before it does that deployment, I can say, and before you actually deploy to Asia, make sure X, Y, and Z is true, and if it's not, I want to fail this pipeline immediately. So again, this is a powerful construct that many teams make use of. A key aspect and an opinion that we believe strongly in at Netflix is this idea of immutable infrastructure. And so when we go into prod, we don't actually build a new asset. We actually take that asset from test and we copy it to prod, and then we put that into production. And Spinnaker supports that first class. And then finally, one thing that Spinnaker integrates tightly with is PagerDuty, because at the end of the day, accidents, things will happen in production. Things always break, and Spinnaker as a platform, we feel, makes it very easy to not so much detect that there's a problem, but once you do detect there's a problem, it makes it very easy to get a hold of the relevant parties. So at Netflix, there is no ops team per se. If you write a service, you own it, and you own it in prod, and when it breaks, you are notified, and you are the one to fix it. There are, at this point, I think there are 7 individuals that essentially are on call 24/7, and all they do is triage. So if there's an issue with Netflix, one of them who's ever on call will get a page, and they'll quickly figure out what the issue is, and they'll figure out it was Michael's service, and then they'll go into Spinnaker, they'll find his service, and then they'll basically page him. And we've seen tremendous value in them being able to do that very quickly. So we integrate tightly with PagerDuty. So you can think again, Spinnaker is this, it's a continuous delivery platform. It's a management platform, and it's also kind of facilitates kind of rapid response. And so in the last few minutes, I did want to talk about kind of something that's coming, because it was asked. Configuration as code. For those of you that have looked at Spinnaker at this point, when it came out, it did not support that. So your configuration was owned by the Spinnaker platform. And we've always known that we didn't necessarily want that to be the end game. We want people to own their own configuration and basically be able to tell Spinnaker, this is my end state that I want to get to. So moving into a more declarative format. We are working on that. In fact, we are actually pretty far with it in this quarter. And so what we're releasing at the end of Q1 is this idea of managed pipeline templates. And I'll actually talk about that in a minute, but that's the basis of declarative continuous delivery. And so those templates, that DSL can be checked into your repository, and that can be your end state. And Spinnaker will just take it during a deployment and say, okay, I know what to do here. I do want to talk about one more thing that I think is pretty exciting. So I mentioned that we're in many different regions. And the truth is that we're a global company. And so when we look at Spinnaker, and leveraging kind of this idea of declarative continuous delivery, is that at the end of the day, if I'm let's say a tier 1 app owner, I can define a couple of, let's say, high-level constructs, like I'm tier 1, I need at least, let's say, 2 gigs of memory, and I'm I/O bound or something like that. Just very high-level things. And then I don't have to do much more. The platform itself can make a whole lot of decisions for me. Because I'm tier 1, I'm going to be in every region. And because I need, let's say, 2 gigs of memory, I'm going to get thrown on like an M5 4x large or something like that. And so the idea here is what we're doing, and this is part of this managed pipeline templates aspect, is that we're building, so at Netflix we have over 7,000 different pipelines within the system. But the truth is that a lot of these pipelines are all very similar. And what people are saying is, I want essentially a best practice pipeline for tier 1 apps. And so this is the idea with this, is that my team will define these pipelines, and in fact is defining these templates, and then other teams can basically say, okay, because I'm X, Y, and Z, I'm going to inherit from that pipeline. And so that's this idea of managed pipeline templates. And we got this idea when we introduced ACA. Previous to Spinnaker, the ACA platform at Netflix actually predates me. I've only been there for 3 years, so it had been around, I don't know, 4 or 5 years. It was probably, when Carl was there. Older than the mountains. But it was a one-off thing, and so once we plugged in once we plugged in ACA into Spinnaker, everyone got it for free. But it was opt-in. And what we realized is that it really should be opt-out. Like, basically, as a company, we've determined that ACA is a best practice, Chaos Monkey is a best practice, X, Y, and Z is a best practice. And so with these managed pipeline templates and declarative continuous delivery, we can basically say, if you're a tier 1 app, you get all these things for free. And so that's where we're going with Spinnaker. So you can think of it more of, we've been calling it, intelligent defaults. I'm actually getting ahead of myself. But at the end of the day, I will explain all these slides. So when you look at Spinnaker today and everything I showed you, flexibility is key. Like, I can configure X, Y, and Z. When I deploy to AWS, I can pick my instance type, I can pick what region I go to, and I can pick like 8 different stages, right? But everything I just described is basically saying I don't have to do any of that. Like, Spinnaker is going to make all those decisions for you, essentially based on what you tell us up front. And this facilitates, so Spinnaker is very flexible now, but as I said earlier, speed is the name of the game, right? You're an app owner. Like, do you really care about like the minutia of, like, let's say, I'm going to talk about AWS instance types, but if you're on Google, I don't even know what Google instance types are. Do I really care? I just know I need a lot of memory. And so when you think about the decisions that this platform can make for teams. We're calling it intelligent defaults, but think of it as like a cloud operating system. When you develop for Linux or for Windows, do you really care about the minutia of the underlying file system and all that stuff? No, you just basically give it a binary. So everything I've just described to you is our vision of continuous delivery and the platform that is Spinnaker and where it's going, is that service teams just need to tell us, here's my binary, it's this, it's a Docker or it's a JavaScript file, and here's my tier and here's a couple other requirements, and I expect maybe a couple things, and then our system will make all the decisions for you and guarantee that it's there safely and done quickly with a high degree of reliability. And you can kind of see some of this right now, like this whole thing about instance types. Like, I don't even know what the latest memory, high memory instance types in Amazon are. I know like they're at the M5s now. At the end of the day, we just want teams, I need a lot of memory, or I need like a lot of CPU, whatever it is, just tell us up front and we'll make all the decisions for you. And think about it from a flexibility standpoint or even efficiency standpoint. If you're in AWS, is anyone here in AWS? I already asked that, didn't I? A couple people, right? You probably use like reservations, right? Reserved instances. So at Netflix, we make heavy use of reserved instances, but we are constantly upgrading that fleet. If we have thousands of microservices in the cloud, if you're running, let's say, on an M5, and let's say tomorrow we get a better deal for M6s, we're going to want to move you to an M6, but right now it's a cat herding exercise. But where we're going is that Spinnaker will automatically do that based, again, because you've told us up front, via this declarative custom, that you need a lot of memory. So that's where we're going. And last but not least, I show you that there's different cloud providers. I talked about how Spinnaker supports Azure, AWS, GCP, OpenStack. At Netflix, we have two different providers. We have AWS and we have Titus. You can think of Titus as our Kubernetes. And right now, we make you do you have to tell us up front, I want this to go to Titus, or I want this to be an AMI and AWS. But where we're going, again, everything I just said, is that we don't care where you want to go. You just tell us what your binary is. In this case, let's say it's whatever, not even a Docker or an AMI, but it's just a binary, a jar file, or maybe it is a Docker. And we'll decide at deployment time whether we're going to put you in a single tenant AMI, or we're going to put you in our version of Kubernetes. So that's the state of the world that's the future world that we see. And we're actually very close to this. I would say within the next 6 months, you'll start to see a lot of these features coming out in the open source world. And I kind of think of it as kind of like a cloud operating system, but it's pretty darn exciting. So I'm done. I did take a little longer than half hour, I apologize. If you have any questions, feel free to email me. My email address is aglover@Netflix. You can, actually, I can't believe I forgot this slide, but Spinnaker is at spinnaker.io. I'll just go to that real quick so you can see that. But if I go to spinnaker.io, you can get all you, whoops. Of course, we don't have that display. Sorry. Gather windows. There you go. So go to spinnaker.io. It's, again, freely available, open source. There's a Slack channel. I'm in there. So is the rest of my team, and so is the good folks at other companies like Armory and Google and Microsoft and whatnot. And I hope to see you there. Thank you very much.
Did you want me to take questions, or do you want to? Anyone have any questions?
Go ahead.
You good?
No questions.
No, I know this man has a question. Yes.
And then they have their own kind of high-level workflow needs. There's another one that was open sourced in Netflix called Meson, which is built on top of Mesos, and it's also very much, a lot of our algorithmic teams use that for sophisticated kind of workflows for algorithms. And those are much better platforms for that kind of sophisticated workflow. Yeah.
Just more granularity.
Yeah. But both those platforms leverage Spinnaker to deploy them.
Of course.
Yes. There's a question in the back.
Is Spinnaker going to support Lambda functions?
Is Spinnaker going to support Lambda functions? Yes, but not right now. It doesn't support it yet, but it's on the roadmap. Surprisingly, for whatever reason, Lambda functions aren't being used a lot at Netflix, but I do hear it in the open source world that people would like Lambda support. We've kind of tentatively put it on our roadmap for Q2, but it might slip to Q3. But we seem to be leapfrogging, for whatever reason, Lambda is going from AMIs into just containers. But time will tell. But I know a lot of enterprises are betting heavily on Lambdas. All right. I won't take any more time of my good friend here. So if you have any other questions, feel free to reach out to me or grab me, or just go to Spinnaker.io and ask it there. Thank you very much.
Check. Thank you, Andy. Off. Yeah. Okay, now do. Thank you, Andy. It was great. Thank you very much, and thank you for coming. Guys, there is a fresh batch of pizza in the back, and there is more beer where the beer comes from. And if you want to stretch your legs and have 5 minutes to grab another slice of pizza, go ahead and do it.
Yes, sir. Let's go back there. Yeah, that'll be a good show. Kind of picked on you a little bit, in a nice way, right?
That's fine.
But don't go too far.
I have multiple questions.
Okay,
to
all right.
ask. And by the way,
Yeah, it makes sense to turn it on.
Turn it off, it actually turns on? Yes.
Yeah, check.
Good.
No. The door is locked, by the way. Don't even try to escape. Неправильно его пронял. Не мешает. Когда доберем? Потому что таковы шансы, что ты ставишь обратно правильно.
Ты не на мюзике, кстати.
Yes. Part of the. Yeah, we're going to take a selfie with everybody from our stuff. Yeah. Just to make sure you remember. John, next time you get your own microphone. You took mine without the permission. Next time, bring your own. Check. No, we need the people. No, we need people. Of course. Okay. Selfie with you I can take any day. Selfie with a lot of people. Also every day.
And next time on market.
This mic's actually hella good.
Huh?
It's a really good mic.
Yeah, it is. I know.
Very intimidating from there.
Yeah. So next time, buy your own. No. But it is kind of. It's like my backup drive. I need to print the sticker for it. Borrowed microphone. Yeah.
He gets touchy about microphones and clickers.
Now, clicker is mine personal. Back and get started because now the real fun begins. Nah, I'm just kidding. But yeah, nah, I'm not kidding. Now it's the good stuff.
Really serious about
Yeah, the serious stuff.
it. So I thought I was set to max, but
Guys, can you kick everybody in, please?
it's not the gain of my mic, it's power.
No, I just, yeah. She's just loud. I am. It's not game, it's just me.
Yeah. That's okay.
And start shouting.
I've known this guy long enough.
We'll work it out.
Over screaming.
Yes, I want to start.
Yeah, Shlomi, we want to start.
Yes. Okay.
Yell into the microphone.
Huh?
Good. Let the tragedy
Begin. Unfold.
unfold. Yeah.
Unfold. Yes.
You're gonna tell them that at the end they're gonna learn a new Greek term?
Yes. Yes. They
If
will.
they stay till then.
Yeah, they will. They will.
Greek.
Yeah.
Like in real life.
We lost half of the people with the door shut. How that happened?
Clearly the pizza is too good.
Yeah.
That was your mistake.
Yeah. No, I shouldn't have let them go.
Next time pizza gets delivered here.
No, next time they don't end until we were done. Yeah.
That's another option. Alright, we can get rolling, get through the boring bits.
Yeah. Okay. No, we need to start with selfies. So I need a full house here.
Yeah, that doesn't.
Yeah, no, it doesn't look good. It's like no one cares about us. Which is the truth, but not for social media.
Exactly. We can't afford that.
No, social media it should be all like full house.
Like I know you polished the hat today.
Right? I did. I got, yep.
Too shiny, man.
Yeah, okay, we can start. Alright, so let's start with important things. We need to take the selfie with an audience. So,
Somewhere here.
Yeah.
And up.
Okay, everybody say what? JFrog! There you go. Alright.
Now
So
that is
now when the important stuff is done, we can get to the fun part. And welcome to JFrog again. We're going to talk about DevOps at scale. And of course, as you might imagine, and most of you probably live it, it is a tragedy. Right? So we'll do it Greek style because those guys knew about tragedies.
They knew their tragedies. That they knew pretty well.
Yeah, and one of the benefits of staying until the end of our talk that you are going to learn a new ancient Greek term by the end of this talk.
Hopefully new.
Yeah, but I guess a couple of people might know. Okay, so as in a good Greek strategy, we start with prologue, and first let's introduce ourselves. This is Leonid Igolnik,
And this is Baruch Sodogorsky.
VP of Engineering in CA.
I run SaaS applications in our security space, and prior to CA, run operations and development for a number of large-scale SaaS products at companies like Oracle and Taleo.
And I'm developer advocate here at JFrog, and if some of you didn't hear me speak, that's my fault. But we just fixed it, right? So everything's good.
So since I work
This
for a
is
company slightly larger than JFrog, my legal team makes me say that. The opinion here are my own and by no means represent CA's opinion. Check.
Good. All right. Now we can get to the fun part.
So what is DevOps?
That's a good question. And as everything in life, it can be explained by a series of Venn diagrams.
Oh, and Greeks love their Venn diagrams.
I think this is what they do all day long. So, first one is kind of obvious, right? DevOps, you take the guys, you take the op guys, you bring them together, you have DevOps. Somewhere in the process, after the term was coined and people started doing that, they realized they forgot something, quality of the software. So they brought the QA in as well, but it was too late to change the name. So it's called DevOps, but in modern life, it usually assumed QA as well. So that's DevOps.
But that's not just it. When we think about DevOps, we think about three other things, right? It's technology, it's people, and it's process. And we're going to take you through all three of this as we go through the story. And for us, for this talk as well, this is also DevOps.
Yeah. And we're going to look at DevOps from this perspective, as opposite to the previous one, which is beaten to death by now by people other than us. Another important aspect of this talk is that we're going to talk about scale. And scale is a scale. Everybody think of scale as of something else. My boss here, Shlomi, once thought that 20 employees. Exactly. So scale is a scale, and everybody can find themselves on this scale that we are going through today. And when you do, when something that we speak about rings a bell of last Friday night, usually when the deployment went wrong,
About
that's
2 a.m.
right? This is where you stand up and shout something acknowledgeable like
Yay.
or amen if that's your thing. Something that will know that
You lived through this.
yeah, and we feel you guys.
Always, we do. We lived through some of this.
Okay.
So we're going to tell you our tale, retelling the story of growth of a mythical company called Pentagon Inc. Why Pentagon?
First of all, they do transactions, like credit card transactions, geography, shape. Take credit cards. I don't think it works, but okay.
But the company started by ex-3-letter agency guys somewhere in Washington, D.C., right? So they picked the name.
Yeah, they have some,
Seemed cool.
background.
So, smart guys actually, really, really good engineers. Few founders, very technical.
We're going to talk about
them.
Yep,
Yeah.
yep, we're going to talk about it. So that was the prologue, and now let's get to the action. 3 acts. First act is called Fire Brigade, also known as Reactive Ops. And
Reactive Ops.
you'll understand what we mean by that by the end of the act. Right, so setting the stage, as Leonid mentioned, 3 guys, 3 founders of a startup, come from the on-prem background, not cloud or something, defense, another pun for their name of Pentagon Inc. I need to explain my puns, it hurts me.
It doesn't work when you have to explain it.
Yeah, exactly, it means that something will
May have to rework them.
right? So smart guys. Yeah, they know what they're doing. A little bit of hipsterish, right?
Yeah, the very cool modern development kind of deployment pipeline toolchain thing, and that seems like they're doing everything right?
JavaScript, Node.js, they do Reactive, they do much, all the cool stuff.
Click to big, straight to production, pretty cool stuff. Right?
So that's the process, right?
But there are 3 of them, right? So
Yeah, so they use
kind of
they use
easy,
agile process like Kanban. Sounds a good fit for 3
something
guys.
basic. They actually, because they're good engineers, they know how to do TDD. They have proper integration. They have automation. They have click to build. So really good foundational start. On the ops side, they said, well, they heard this talk at one of the O'Reilly conferences, says no ops, and they decided
They all come from dev background.
on-premise. Like,
Yeah,
where
and
you kind of ship this thing, and like, what do you do with this?
Ops is not their cup of tea, but you know what? Today we don't need ops. It's all no ops, it's all on the cloud. And more so, they don't even need servers because it's all serverless, no ops. Right?
Yeah.
So who needs ops?
Well, on the tool chain, they picked up a reasonably good tool chain, right? They started with Atlassian, like a lot of smaller companies do. GitHub is readily available off the shelf. They picked up a CI solution, and what was...
Who knows what Travis CI is? Yeah, okay, good amount. So Travis CI is a CI server on the cloud. Serverless, no ops. It watches your GitHub repositories and builds when something is there. And they have those plugins, those deployment plugins, when something is being built, eventually it is get deployed. There are a lot of plugins for Travis CI, Bintray,
Artifactory?
Bintray. Bintray, they have, of course, Heroku, a bunch
Beanstalk?
Beanstalk.
Like those guys picked?
And this is how it works, right? Very minimalistic toolchain that just works.
Well, so let's see what happens.
So, let's get to the action.
So, like a good startup and first scene, there's a lot of work to get to the first viable product and a lot of waiting, since they have no sales, for the first customer at this stage.
So they actually wait. And then good thing happens.
They get the first customer. Well, what do you do when you get your first customer? You drink lots of alcohol.
And this customer is some kind of, internet age celebrity that has...
Kim Kardashian?
I don't know.
No promotions allowed?
No. Some internet age celebrity that have their own fashion line, and they decided to trust those guys with all their credit card transactions.
They launch on Thursday, celebrate, and go home. Friday is a day off.
And then this happens.
Nothing works.
Call from a customer. Remember, the only customer that calls them 2 a.m. with the words, nothing works.
So what's the natural reaction? Panic.
Now, remember, we're talking about 3 founders, all 3 of them very technological guys. They built them with their own hands. So they know exactly what to do. And they charge.
So easy. There's no ops, everybody has a root. So everybody's on production, likely drunk, and this Friday at 2 a.m. at the end of the day. Where are the logs?
Which logs?
Well, from like those 7 microservices, because I don't know which one is the broken one.
So there is an exception in this log, and it shows 3 a.m.
Well, and in mine it shows 4 a.m. I'm confused. Wait, but the time zones are not the same.
How that happened?
I don't know. Who chose the time zone?
I'm too drunk to think.
Well, it just happened, huh?
Yeah, this is what happened. And eventually they managed. And again, they're 3 brilliant guys.
Some time zone acrobatics, some log digging through hundreds of different files on different machines.
And they found the problem.
It happened on Thursday.
It happened during their crazy party when everybody were drunk. One of the founders, had a great idea.
That feature that you were asking about, I committed it.
Right into production.
So it should be easy, right? Like, we know when it we have Git, we know we have continue. Let's just go back to that build.
We can take the previous.
Yeah,
we can take the previous commit.
Nobody's using it. Let's go to bed and
run it.
And then, what was that Monday?
And then something very interesting happened. The previous commit that was in production, that was built successfully, won't build anymore.
Yeah, dude, I don't know what's going on. It says it's a file is missing from
Missing dependency.
NPM thing. It can't download it.
So we have a missing dependency that was there on Friday morning. What happened?
Someone deleted it.
Unpublish happened. Who remembers the great unpublish in NPM?
Uh,
Left pod.
The LLM
pod,
gate.
The NPM gate. Someone deleted their package from NPM registry. Here, Ben knows exactly what I'm talking about. Good job, Ben.
Give us an eye. Oh, you see.
Right? And, I'll tell you later who Ben is.
All right.
Right? So what are we going to do? The build won't run anymore. Eventually, of course, they manage.
Lots of hard work. Lots of rewriting on the fly in the middle of the night. Rarely a good thing to do, but you know, they have a customer, they got to get them successful. They get together on Monday and they decide that something has to change.
The problem with that is that week after week, night after night, weekend after weekend, they run to those situations again, right? Because do they have time to clean any of the technological depth that they get on the way? Not so much.
Have they experienced enough pain early on to feel like that needs to be fixed? Probably not yet.
All the adrenaline from starting up
It is
still there.
like middle of the night firefighting could be cool.
But eventually it's not cool anymore.
Like a good bucket brigade, right?
Right. And then we get to the second act.
So in the second act, we'll tell you the story of the evolution of the company into the next stage along that scale of scale, the reactive improvement. We also call them the smoke alarm installers.
So what happened with our company? First of all, great news, round A.
Yay! Drinking?
Absolutely, always.
That's
Right? So they got some money. They got some new developers. There are 30 people now.
And one of the dudes actually used to be an ops.
Here we go, and let's see what happens next. So they have around 100 customers. They are getting their momentum. It's, as we make technology, will pick up the phone and they won't be the founders. Process evolved as well.
Naturally, as the company grows, they realize that with that many engineers, Kanban doesn't work for them anymore, so they go to Scrum or Scrumban, somewhere in between. Their tool supports them. They can continuously evolve, so it's all good.
Who knows what explanatory testing is?
Exploratory.
Exploratory
Say that fast
testing.
3 times.
Who knows what it is?
So
Someone?
actually-
Someone?
No,
Oh, here you go. What is that?
It's basically testing on the fly without a plan.
Testing on a fly without a plan, that's a great description.
So-
It's basically manual QA. Manual QA doesn't sound sexy anymore. Exploratory testing does. So now they have manual QA,
Good one.
right? Oh, and they have this ops
They
guy.
have that guy.
And he knows that ops exists.
and he understands what to do. Right? So they fix some of the problems we've seen in the first act.
They know that serverless means there is a server, not just
Somebody else's one.
Yeah? And they know that no ops means there is ops, but someone else should take care of it.
So the ops guy decided that, it's time to change a few things. So they also changed the processes a bit more. So now they have this thing called the developer on call, right? We just heard in the previous talk, at Netflix there are only 7. Well, they're a small company, but they have one. They decided that everybody waking up in the middle of the night is really counterproductive. But what is that developer on call to do? The system is big.
We'll talk about that. So, but they do have someone who is from the development team that helps the support guys, right? And they decided they all moved to London. They all moved to Greenwich.
So they fixed the time zone problem.
They fixed the time zone problem.
No more time zone acrobatics.
Well,
Thank God.
I'll tell you what. Turns out that the real estate in London is about the same price as in Silicon Valley, so they decided it's not worth it.
So they fixed the time zone, actually.
Instead of moving to London, they just figured out the time zones.
Maybe an easier solution. Naturally, the tool chain has evolved as well.
Of course. So now they have support teams, so they naturally need a knowledge base, because the support team need to find those answers somewhere. Confluence is a natural choice. It
So
integrates well with
other
Jira.
new developers beyond the original 3.
Of course. GitHub stays, private CI is just fine. Here you go, Artifactory. Now they realized that they need the control of their dependencies, and also they need the build artifacts so they can select among them the ones that should go to production, and they need to be able to go back to the good ones when they screw something.
Some of the best lessons are learned at 2 a.m. in the morning, aren't they?
Right?
But more on that later.
Beanstalk's still valid, right? The platform is great, but now they make a lot of sense of their logs using a tool like Sumo Logic or
Logly or one of the many
there are
log
a bunch of
aggregation
others.
tools.
We love Sumo Logic, so that's a good choice. There are others as well. Sumo Logic let them gather the logs together, correlate between them, query on them, build dashboards.
Write
also-
alerts.
Right.
Things go bumping, right?
Alerts. Good that you bring them because they have another tool. Who remembers what pingdom is? No one. Okay, so I'll tell you what. Pingdom is the father of APM, of monitoring.
Sure.
It is. This is a very smart monitoring system that all it does, it goes to your URL and checks if it returns error or not. If it doesn't return error, all good. If it returns error, you get an alert.
You mean they know what to test? They do that, and they do something with that.
Exactly, right? So that's a very, very early monitoring. It's better than nothing. So let's go to action.
So, well, what happens when we raise more money and hire more developers?
We drink.
We drink. But then we get a call from a customer.
Friday night, a
2
call
a.m.
from
and
a-
a.m., nothing works.
No, nothing works. That could not happen anymore because we have pingdom. So nothing works, we will never hear again. What the customer
So
says...
why did I get that call? What the hell's going on? Everything's green.
So the customer says, look, there is something strange going on. The Visa and MasterCard transactions are fine, American Express transactions fail.
And I'm getting old of those random errors, guys. Like, this is not the first time it happens.
What do the guys do?
Panic. That's the natural first stage at 2 a.m. in the morning on Friday when you're the sole alcohol who joined the company 3 weeks ago. You don't know where
And
to go.
already drunk.
But you go to Confluence and you have a knowledge base. And in the knowledge base it says if something happens in this area of the problem, go to the subject matter expert list and call that dude, Dave.
Dave, by the way, just celebrated their first round for a month now, so he's not in very good condition by now.
He is busy. So we look at the knowledge base, we start mining through the logs because we have a product like Sumo. We finally look at the builds, nothing recently changed. We have a good history. We try to reproduce it in development. Nothing happens in the lab. So we keep digging. Lots of hard work. Eventually to find the problem was one of the queues.
Well, Dave eventually woke up and told us that His decision was that since American Express transactions are significantly less in amount comparing to Visa and MasterCard, he just allocated less resources to American Express transactions.
Seemed logical at the time.
But our customer had a promotion. Whoever buys with American Express gets one free. So the American Express queue exploded. Do we know what to do?
Well, we fix quickly, and then we get together for a retrospective, right? And then about this stage, and that's why we call this act reactive improvement, a methodical process of making sure the same problem does not occur again starts emerging at the company, right? Typically, those processes materialize in something like a root cause analysis document. Like here's an example, happens to be from my own product. We redacted some names to protect the innocent.
Total, not so innocent. Total time services affected more than 24 hours. Not very innocent.
Innocent enough. Pain was instructional in that case. So in a typical RCA, what you really need to see, and it's a good practice to have because it's a forcing function, is a time of the event. Meaning you probably don't want to be reconstructing that timeline post factum from memory, right? So traditionally, teams that use Slack will have a little channel where events get logged as they happen, right? You have an action log, because sometimes when you do the retrospective 3 or 4 days later, trying to figure out, was the queue overflowing first, or was the server down, or was it Amex, right? So here's an example of a timeline of the events from the moment of something failing, somebody being paged, somebody notified, etc., etc. And those times are important, especially as the companies continue to evolve and you start bringing more operational processes, like SOC, which is a standard audit process.
Well, we'll get to that.
Yeah, but they were smart. They had that ops guy. So that's your events section. When you go to the next slide, right, you always have a brief description of symptoms, and that's what you typically eventually will use to populate your knowledge base, because sometimes problems do come back, right? There's an analysis of what happened, typically written in a free form, and then the most important things, finding the actual root cause. In our case, the queue was misallocated, and figure out what would be the next steps to make sure that there's a smoke alarm or something like that, and this problem never happens again. Or if it happens again, there's an alert linking directly to a knowledge base saying, well, when this happens, you go do this. So in the middle of the night, you don't have to think about that.
And here are a couple of interesting observations. We'll get to next steps and how we actually can decide what to do in a second. But this root cause analysis not only serves the purpose that Leonid just mentioned, which is how we build our system resilient to this problem, or how can we solve this problem quick enough that no one will ever notice, but there is a huge psychological effect. All of you, I suppose, heard about GitLab 2 weeks ago. The great, I don't know if there is another word than fuck up to describe what happened. Let me put it that way. I took a second to think about it, no ideas.
In the corporate terms, we call it reputational risk.
Oh, thank you. That was what I'm looking for. Thank you. Right, so if you remember, they deleted some production databases. That happens. Who of us didn't delete the database in production?
Stuff happens.
But then they had 5 different types of backups. None of them was operational to restore.
And that is scary.
Right? So, except taking that aside, they were very public with their retrospective. They did it live, actually broadcasting the whole thing on Twitter. They released a couple of very detailed blog posts about what happened and how they make sure it won't happen again. Not only they did it because they feel obliged to their customers, but there is something very interesting going on in our industry, and we as JFrog see it, and you see it as an NCA as well. Surprisingly, the users and the customers are extremely forgiving. Almost any reputational hazard, any fuck up, when it happens once.
Once. You're allowed to make that mistake once.
For a second time, you will be out of business.
You will be, absolutely. And like those documents, and this is an example of the document on all of my products that I've run, shared with customers. We talked to the customers, and I heard time and time again, I had customers as small as a few hundred employees and as large as a Fortune 100 companies. First time, they will understand, and the most important section they want to talk about is this section, root cause, and what are you going to do about this?
Getting back to our story, if you remember, the root cause was queue overflow. How do we fix it? First of all, purge the queue. There was like Amex transactions, who care about them, we can delete them.
That's customers, who needs that?
Right? And then, the fix is easy.
Smoke alarm.
We need to increase the size of the queue. Dave, the good guy, says, I will increase it. By how much? Double?
42.
Let's triple it.
42.
42.
That seems as good of a number, I think.
Right? So we just guess what will stand.
Have you ever done that? Like, maybe we'll size it like that.
Yeah. Okay. But sales do it with their prices. We do it with our tech.
It's all fair game.
So, this retrospective is extremely important, and that's exactly what makes the reactive ops to the smoke alarm stars that make sure that it won't happen again.
Every time something happens in your process, production environment, development tool chain, a particular defect gets introduced into the product, you do your deep retrospective and you put in place either change to the process, change to the code, change to the monitoring system to make sure it doesn't happen again, with a caveat of not overreacting, right? Early on, when you see companies shift into that stage, everything becomes a root cause analysis and everything requires an action. And typically about 10 to 15% of the incidents that do happen, there's really no further action, right? It happens, it was a fluke, we decided that the action is too expensive. But it's important to make sure you go through that process methodically and you hold with yourself and your customers, both internal as well as external, because at this stage of the company, there's support, there's sales, there's marketing. There are other folks outside of the engineering organization who want to know that you have your stuff together, you've done the proper diligence on what happened, and it won't happen again.
You publicize it, you get with this to your customers and your users, and you said, this was the problem, not going to happen again because we did that. Act 3, which is of course the tragedy culmination when everybody dies, it's here.
It would be a Greek tragedy if everybody didn't die.
Right, and we call it the perfect storm. So what happens? What happened?
Well, let's see. So we've got more people. We closed more money. A VC wrote us a check, so we hired more people.
Amen.
74 in engineering.
And that's not including the ones that we have already. It's a 100-people team.
5 with ops background, actual ops people.
See? A whole performance engineer, like a whole guy made of performance.
Well, we were lucky we found him. Like, those are mythical creatures, those performance
Absolutely.
guys.
Another mythical creature.
All hail to the chief.
Yeah?
Because somebody realized that, microservices, we now have 60 of them. It seemed like 6 or 7 different storage technologies underneath, maybe.
5 non-relational databases?
Yeah.
Easy?
Well, somebody read an article on the internet the other day.
Yeah, exactly. We need to bring it in.
So we hired a chief.
Customer success team, what are those?
So, customers inevitably create interruptions. I'm sure all of you who work on software that has customers realize that you can't live with them, you can't live without them. So, the challenge becomes is how do you stay responsive to the customers without creating a lot of context switches in your core development team. So typically at this stage, you see a dedicated function emerge within engineering, and really their job is to be interrupted. Somebody who's actually a firefighter. He doesn't like working on long-term, drawn-out features that may span 3 months. He just likes context switching. Or as one of the panelists at the panel bar of night did said, find somebody with ADHD and put them on that team. Right? They like those context switches. The team, they just enjoy doing it again, and that's what makes the developers not do stupid things. So they will handle the very, very urgent problems, delegate the rest of the things to the core development. By no means your old sustaining style team that just fixes bugs, right? They're the triage.
We put this developer on call, and we multiply it by the subjects that we have. Now we have a subject matter expert for every subject in our system on call, and this is who those guys are.
No, not really. The on-call guys still come from the team. Somebody from the core team owns their services. They still go on call. But during the day, those are the guys that get interrupted. By no means this is replacing scheduled teams that know the code. Everybody goes on call.
They have a legal guy.
Oh, yeah, the legal guy showed up.
This is the stage. They have a legal guy. CFO,
Yeah,
someone
yeah,
who actually Nobody cares about expenses.
Well, the VCs made them hire one, right?
Of course, but no one's because no one voluntarily will hire a CFO.
And they've grown. It's about 1,000 customers. They're like a real company now.
Nice. What's going on in the process?
Well, they've realized that not only they have 74 engineers in addition to the ones they had before, they're also in more than one location. They just can't find everybody they were looking for. So they started looking at Scrum, and Scrum doesn't really scale across more than 5-6 teams very well, and they're well beyond that. Like they're about 12 Scrum teams, probably 13, 14, couple locations. So they went one level up, and they took this process called SAFe, Scaled Agile Framework, which is a minor lightweight framework above Scrum that helps with things like architectural runway, so the chief has somewhere to contribute his backlog.
We're going to talk about that.
They created a system test.
And that's again the chief architect that knows that there is a complex system built of a lot of small microservices
That has to come together in production environment. Realize that somehow you have to make sure it did come together, and it's developed in different sites, probably by different teams, with slightly different practices, right? Because you're rarely able to replicate consistent practices across multiple sites. So they have a lightweight team that helps with frameworks, automation tools, right? So the reform way of managing this, managing the labs, managing the testing process, making sure that the software that goes to production can be tested in an automated fashion.
And now there is something I'm going to say that you need to start throwing stuffed chairs on us. That's a good idea. They have an ops team. And you should go, what? Are we talking about, thank you, Shlomi. Are we talking about DevOps?
And Baruch and I did this talk in a room with a bunch of only developers who
Right,
always
and
threw
they're
chairs
like,
at us.
and they're like, what? DevOps is not having the dev team and not having the ops team.
Who needs those guys anymore?
So what is this ops team? And the answer I give them is, breathe. This is not the ops team that you remember. Those are not the system administrators that are going to set up the servers for you and take whatever you throw over this wall and take it to production. Those team, they build the product, they create the tools.
Things like Spinnaker.
They evangelize the methodology of DevOps to the whole company, so the development team could be DevOps. Escalation path.
We're a big company, 1,000 customers.
We already had that. From the support guy to the developer on call, that's an escalation path.
And then what? What if the developer on call can't solve the problem? Where do they go? How do they find help in 74 people across multiple countries and a couple sites? So typically at this stage you also have a second, sometimes third tier escalation, and quite often those escalation paths are written all the way to the CEO. With very well-defined timeline saying if you can't solve the problem in a couple hours, you call the manager on call. If you can't solve the problem in X number of hours, depending on the business you're on and depending on the severity, and that's the other thing that emerges in this stage, a very formal defect, and for you wake up and find. Sub 1, we kind of should work with it until we fix it. Sub 2, we can wake up and deal with that tomorrow. And 3, well,
Who cares about 3?
It will go into the backlog.
Right. And CEO, Shlomi, did you know that you are on the top of the escalation path?
The best technical guy in the area.
The interesting part is that you don't need to be technical guy to be on the top
The
of the
goal
escalation
of
path.
having your CEO on the top of the escalation path is to make sure nobody ever has to call him. It's very simple. It's motivational enough when on that page there's a cell phone of the CEO and you know that the clock is ticking towards the time you're supposed to call him. It's amazing what happens. I've done it multiple times. I work for a company with 13,000 people, and we have an escalation path that goes all the way to the CEO. It's amazing what happens.
Oh, here's your beloved SOC 2.
Oh, my beloved SOC 2, right? They're a public company. They're not public yet, but they have customers that are public companies. They have their own cuts. So there's a very common standard called SOC, Standard Operating Controls for Service Providers, right? Formerly known, in my lifetime it used to be SAS 17, now after that SAE 16, they finally renamed themselves into SOC, that describes a standard set of controls the company needs to have defining how they operate the environment. Things like separation of duties, right? Ideally, a person that wrote the code shouldn't be approving it for production promotion, especially if it touches money, like this particular company.
Now, this contradicts everything we are talking about today. right? It also prevents people from having root to production environment. So if Netflix were applying to SOC 2, they wouldn't allow to do what they are doing.
Well, I suspect actually Netflix may be applying SOC 2, but the beauty of SOC is you get to choose which controls you want to fulfill, and you just get audited either by your customers or by an independent auditor as to what controls you committed to fulfill and which ones you actually fulfill well. Like, for example, when you offboarded your DevOps guy, did you disable their production access?
Exactly.
Oops.
Non-functional backlog, that's again something new. We have this performance engineer that actually cares about performance.
And the chief?
And those two guys run around and say, you know what, except the features, you also need to make sure that your system is fast enough and not just
Elastically scalable, performance measurable, self-degrading, self-healing, and all those other good things.
All those are going out to the backlog. Tools, again, evolving. So we have a configuration management now. We also have a real APM. Now, if you remember this pitch dump that we had previously, Ping Dom, it was nice, but the real APM is really what should work.
And the ultimate goal of an APM product, and there are a number of them on the market, there's one from C8, there's New Relic, there's AppDynamics, there's Dynatrace. The primary goal is to gather the metrics from your production environment, live production environments, and to feed two things. Feeds your performance engineers about this continuous system behavior and how it evolves. And ideally, a good APM system gives you a vector into the code when you have a performance problem, right? Today's modern APMs instrument your code either through bytecode instrumentation on Java, monkey punching on Node, CLR, bytecode manipulation on .NET if you are unfortunate enough to run on a CLR. My condolences to you.
No,
but
NPM, no condolences for NPM?
No, actually, Node monkey punching actually works quite well. What performance problem in the event driven system? It's all infinitely scalable now. So, but the good APM system gives you a vector into a code line, ideally into the code line where a particular performance bottleneck is occurring, so you can react much faster.
All that is great, and now let's see how that works out. So, they raised more money, remember?
What happens when you raise more money? You drink.
And then, something funny happens.
And then, the Greek tragedy ensues.
Well, now this is something interesting. The customers are perfectly happy, and our legal guy comes to our head of engineering and say, I attended an amazing legal conference. It was the hardcore stuff.
Best legal minds in IP litigation.
Amazing conference, very interesting. I couldn't take my eye out of the slides. And they told me that you are not allowed to use LGPL version 2.2 in production.
Huh.
Do you use it?
Huh. I don't think I know. So let me call my manager, see what happens.
The manager actually takes the developers and make them dig into their systems to find their dependencies.
A minor number of few thousand dependencies.
Of course, and the deadline for release is tomorrow, of course. And if they find this LGPL 2.2,
we have a problem. Well, that's just one of the problems at this stage. Our CFO comes to us and goes, Baruch. So the board asks for the projection for next year. You know, we did the revenue targets, we have the sales targets. How much money are we going to need to operate the environment?
Best thing I could do, is taking what we spent this year and add 20% for next year.
Are you sure?
No,
Because I'm going to the board, they're going to put it in laminate, they're going to hold it against us.
Trust me, if I will need more money to run production servers, you will give it to me.
Uh-huh. Okay. Well, the next one is...
Who knows what that is? Will it blend? Our twist on will it blend is, will it scale?
Baruch, I just talked to the head of sales. She has this amazing
She, by the way.
Fortune 50 customer. And they want us in the contract, because the legal guy said it's okay, to commit to some scalability numbers. What can we commit to?
You ask me, will it scale?
Yes. Will it?
You know what? I have a solution for this one. No panic. I will ask my guys. They wrote this code. They should know. And my guys go like, of course it will scale. We wrote it. Sure it will scale. Absolutely, no doubt about it.
We sign the agreement. The customer goes live.
And before that, you might wonder, how do we know?
Yeah, how do you know, actually?
We wrote it. It should be fine.
42.
42. And then, this happens.
Let's hold them at the gates.
Whoever doesn't recognize this picture is this movie 300, about 300 Spartans. They're all dead.
But again, if you have to explain the puns.
No, that was good. They were dead in the end, so it didn't scale.
Well, and it continues. Hey, Baruch, so we're expanding as a company. And, you know, North America, we have good markets. Time for us to go international. But we do have some customers that don't like this whole Roman thing.
They want it in ancient Rome now? In ancient Roman? But we should be fine. I'm not sure, but I'll ask my developers, and they will tell me that everything is fine. We translated everything, right? And everything now is ancient Roman.
We tested it in Pig Latin as well.
Well, except of the numbers.
Oops.
Who thought that those little pesky Romans don't use normal numbers? No one translates numbers, right?
Yep.
So, well, so everybody's dead. But we are in the United States, and that's not an acceptable answer. We need to oblige to California's rules of filmmaking, so we will make a happy ending.
There will be.
And that's an epilogue.
Smokey the Bear, the proactive improvement stage of any development organization. Right.
So, there are solutions for all those problems. Why people won't use them?
Well, here's what I've learned over the years of doing this. Certain types of problems have to be solved at a certain level of the continuum of the scale. Try to solve some problems too early, you won't be successful because the team is not ready for it, you're not ready for it, right? And you're going to be wondering, why would I slow myself down with this extra process, right? Whether it's RCA, whether it's the developer on call, whether it's the localization or scalability testing, before I really need it, right? And the tricky thing for us, you're scaling through this maturity process, is to make sure you do in just enough process, just at the right time, just at the right level of the scale. The other thing I've learned is as you take the teams through this scale, you can't skip forward, right? The laws of physics dictate such that you have to go through this evolution from a bucket brigade to reactive improvement to proactive improvement, and I've never seen a team skip a stage. You may go faster through a particular stage, but you typically have to go through all of those stages because pain is instructional, and it's not because I have no empathy, which I don't.
That we know. So now let's talk about the ideal world in which all of the problems that we saw are actually solved.
So how do we change the process? Well, we start looking at performance and scalability testing. A lot of companies, before they arrive at this stage, find themselves in a very interesting situation. They have all the data, but they don't use it. Right? There was APM, but nobody was looking at APM until there was a fire. Right? License and security management starts materializing because at some point the company gets big enough and the customers are starting to demand and the risk gets higher. Proactive performance and test reviews start to emerge based on the tooling, right? That goes back to you have the data, you have to start using it and not stand in front of a speaker. And non-functional definition of done start getting established to make sure you don't get yourself into a problem.
That differs from the non-functional backlog that we spoke about earlier. Backlogs are fine for deferring things. We will put it on a backlog usually means chances are it will never be done. Definition of done is the opposite. It means you cannot cut a release without meeting the non-functional requirements.
And ideally, those non-functional requirements become transparent to your teams, right? Whether it's a microservices templates that includes metric instrumentation, monitoring, log aggregation, all the standard things the chief and the DevOps guys decided on, right? That's the easiest way to do that. Take those best practices, codify them in software or in a platform. Again, there was an example of that in the previous talk, where how Spinnaker and Netflix did it. And make sure they're very easy to inherit.
So that brings us to tools, because this is how we implement processes, and of course the tools evolve with the process itself. So a couple of tools here are intended to solve the problem that we saw, and we'll talk in a second on how to. We have JFrog mission control now that allows you to predict what will be your usage, how much resources you will need. There is JFrog X-Ray here that will help you with the security and license management to solve the problems that we spoke about. BlazeMeter,
A good performance testing tool, CA happens to all, but there are many others. So you do need something to generate a realistic load on your production environment, in addition to using tools like Sumo and APM to get the performance characteristics of what you have.
service virtualization, like Spinnaker, which actually helps with managing the resources correctly and going to production faster. And those tools solve the exact problems that we spoke about. So the problem of the two social, legal that we have now that goes to conferences and discover things that we don't like, that can be solved not by legwork, but using a tool like JFrog X-Ray. And you can see here an example of the recursive analysis, impact analysis that X-Ray done on a certain Docker image that discovered there is a variable jar somewhere 6 levels buried into it in a war, in a zip, in a Debian file, and there is a problem right there. And this can be and should be plugged in your CI process. So the next build you do after a developer introduced this dependency, you will find it on any level of your component tree.
I think the legal guys in corporate speak nowadays call it software composition analysis.
That's a fancy word for what X-Ray does. You remember this guessing of how many resources we will need next year?
Well, hopefully you have a tool in your development process that helps you understand where is that you are investing your development capacity, right?
That's a very advanced tool. It's called Microsoft Excel.
Pretty much. And here's an example from one of my older products, right? And you try to create really broad business kind of making sense categories amongst which you distribute your investment. Things like quality improvements, things like corporate initiatives. If you work at a larger company, that tends to issue mandates. Fulfilling customer commitments, especially the ones that sales makes, reducing MTTR, for example, mean time to failure, right? Hopefully, you don't need a fancy tool, but hopefully you have the tool that can give you the data so you can look at those investments and manage your investments in development like you would manage your own retirement portfolio, right?
Your R&D, but most of the money goes to keep the lights on, right?
Things like roles and responsibilities start emerging to make sure that it's clear both to existing teams as well as the new teams. Here's another example of what we've done with a matrix to help understand who's going to be responsible in the process. And this is for a sizable team, about 200 engineers, 6 locations, and about 22 Scrum teams, right? Color coding each stage of the development deployment pipeline, this happens to be for the on-premise products, to make sure those responsibilities are well understood, right? I have always an ask for folks that work on my program management team that anything that describes who does what has to fit on a piece of paper that can be pinned on a cubicle wall, right? Because if it's more complex than that, nobody's going to ever find it or use that. And here's an example of how you can structure something like that.
That's another example of how you can predict your usage, and that's a screenshot from JFrog mission control. And what you can see here is allocation of storage on your Artifactory repositories. Now, that's important by its own, because you probably pay for this storage. But the bigger picture of what it shows is much more interesting, because this shows you not only that you will have more files, it shows you the artifacts, the growth in your software development, predictable growth in your software development, that now you can make estimations to give better predictions of what is going to happen next year. How do we solve that problem? Quality one, you mean? You know what? I'll hide the next slide, and I want to ask you something. How do you know the quality of your product? You should participate. It won't work otherwise.
Like, is it good? Is it getting better? Is it getting worse?
How do you know?
What do you measure?
How do you know?
Number of reports.
Here you go. That's perfect. Thank you very much. The only valid indicator for the quality of your software is what your users say.
How do they say it?
All it matters.
How
the users express how they feel about your product.
They call support. If support can't solve the problem, they open the defect.
So, defect opened by support is the only valid metric of quality of your software. This is one of yours, right, Leonid?
This is from another product that I managed a number
I
of
want
years
to
ago.
say that this is a particularly shitty product. 65% of the open defects are either S1 or S2. Am I right? Is it that bad? What do you say?
Is it bad? Is it good? How do you decide?
Anyone thought that that's not?
Catastrophic doesn't sound good.
Okay, so people agree with me. That's a shitty one. Anyone disagree?
I would compare with previous releases or...
Okay, so compare the trends over time is the suggestion.
That's good. But any other reason why this picture might be misleading and it's actually not that bad?
So here's another interesting way of looking at the defects. How many of the defects that got open actually resulted in a bug fix, right? How many of those defects that
Now,
came from
this
support-
answers a very important question. The only two reasons this picture may exist is it is a shitty product. Your support is completely unqualified to do their job. They don't know the product, so every time they get asked, they say, well, it's a bug. Because they don't know whether how your product should perform.
As a head of engineering, I can tell you, back of a napkin calculation, anywhere you work in the world, the development day costs the company anywhere from $750 to about $1,500 a day. Typically, a developer will be able to deal with 2 to 3 defects per day, right? So when I look at those numbers, well, that's an expensive proposition, right?
So, how do you decide whether you have a shitty product or your support is just not good enough to answer the questions?
Well, we start looking at resolution type, right? Every time we resolve a defect, we start looking at what was the defects that were actually resulted in the code fix, like that little number there, 13. And how many of them was information provided, meaning a developer had to look at the defect and go back to support saying, well, here's the actual problem and there's nothing for me here to do.
That's not a product problem. So, and what we see here is your product is actually much better than we saw on the previous slide, because more than 50% of the problems that support thought they are problems, they're not problems. The support just does not know how to answer that, right? The bad news are your support team is probably not very good.
Now, if you don't have this data, having this conversation with the support team is nearly impossible, right? And that's why data management and quality of your data when it comes to your backlog and your defects becomes extremely important, because you can start making real decisions and have real conversations, because it's tough to argue unless they bring to the table alternative facts. But that's for a different talk.
That's a different talk. Okay, I promised you a new term from Greek, from ancient Greece that you didn't know. That term is epimyth. Someone knows what epimyth is?
Let's see.
No,
So far we had limited success with
well, the only limited success means the only person that knows what it means is my wife, because he has a major in theater, so she knows. Epimyth is the moral of the story. What we call in Hebrew mashal. Picture.
You cannot go along the scale of DevOps unless you evolve all three, and you have to evolve all three at the same time. Whether it's the team composition, having just enough process in your team, or having the right tools to support those processes, right? Those things have to go in the right order.
Yep. And talking about order, I think we have a technical problem here. Yes. So our slide went well. went bad. The two things that you need to take away from this slide is, and from this talk, is first, the principle of DevOps of you made it, you own it, is extremely important. And the only way you can learn this principle is by pain. Pain is extremely instructional. With that, couple of housekeeping items. First of all, Stephen and Cheryl made me put this slide on with a severe physical pressure.
But credits to them, it's in style.
Right? Jokes aside, guys, we're hiring like crazy to solve a lot of the problems that you saw, and you, your friends, your people that you refer can help us getting better in this DevOps journey, so please send them to us. It's also a very nice environment to work. You get to hear Leonid from time to time.
I wouldn't consider that an advantage, but...
Oh, it is, it is. Q&A we will do now. Couple of links before we go. That's me on Twitter, JBaruch.
That's me on Twitter,
Leonid Golnik. JFrog.com/show notes includes a special page that contains all the resources for this talk, including the definition of the word epimyth, by the way. Right? Video will be posted as soon as John will produce it. John, I need to commit to the number here. 2 days?
That's
2
what
days.
the website says, 2 days.
2 days. So, John, in 2 days will you... Huh?
42. No.
Hours.
Hours. We can do that.
Thank you, Shlomi. John, the boss said 42 hours. Slides are already there, so you can go there and browse through the slides again, because they're absolutely awesome. Lots of links, including, as I mentioned, Epimyth, feedback form to tell us how awesome we are, and the raffle. Now, just for sitting there and then going to this page, you have a very good chance, there is not a lot of people here, to win an amazing Amazon Echo Dot.
And the page is mobile friendly.
And if you come early, you can double or triple your chances. So you should go there now. And Q&A.
So questions?
So first of all, thank you very much.
Thank God we're not in Rome bar, they can't do that.
Yeah. And now, questions.
We're not letting people out of the building without...
We
few
need 5 questions, otherwise you stay here.
That's the
Oh,
bottom.
here you go.
There you go. We got the first one.
I'll help you get out here.
Thank you. Appreciate it.
So, don't you still have a shitty product though? Because your customer filed a bug, right? So, because the customer's always right.
The customer is always right.
And so, I think your validation to say that it's not a real bug because I didn't cause it. I don't know.
It's not the validation.
It's not
So
good.
the message from the slide we showed is you have to fix the defects in the right place, right? And when you do your root cause analysis, whether it was a code fix, which you figure out how you code that and what are you missing in your development process, whether it's automated regression, whether it's the system test tools, etc., or whether it's training that you need to deliver to the support team, which, by the way, typically falls to the engineering team and the product management team nevertheless, right? The quality of the product is different. And we kind of tend to separate the quality of the product from the quality of the offering, right? And the customer obviously consumes the offering. And I absolutely agree with you. And that's the data we use to decide what needs to be fixed, right? In this particular case, when you come in and when I joined the team, this was about a quarter or two after I took over the team, it wasn't really obvious. Do we have a technical problem? Do we have a people problem? Do we have a process problem? And without this data, we would never zoom in on the right area of the code. So I think the message here is have the data and use it as information to act on, right?
Yeah, and I would argue that maybe you don't have an intuitive product or, you know.
Yeah, it might be usability
There are variety of
issue.
issues, right?
Absolutely, yeah.
So that's one.
4 more to go, and you can leave. Tali, you have a question? No? Should we let them go?
All right?
They want to leave.
They want to leave.
Yeah, they want to go home.
All right. Well, thank you. Thank you very much, guys.
Thank you, guys.
That's the